differential equation we call homogeneous equation. For homogeneous equation, we define any first order differential equation that you can write term dy by dx as a function of y over x. Then we would call that equation is the homogeneous equation. And the way that we find the answer for this type of differential equation is just that we assume v is equal to y over x, and then we are going to change the differential equation from dy by dx to the term of dv by dx. And by this assumption, then we can be able to write dy by dx in the term of dv by dx and v by using this definition. Okay? From whatever we assume like this, we would get y equal to vx. And then we do differential of this equation respect to x. So we would get dy by dx equal to x dv by dx plus v dx by dx. dx by dx is equal to 1. Then we would get dy by dx is equal to x dv by dx plus v. And then we put these two definitions into our differential equation. As I said, that the homogeneous equation is the equation that you can write term. If you have the differential equation like this, you got to rearrange it in the term of dy by dx got to be a function of y over x. Any differential equation that you can write it in this term, then we call it homogeneous equation. Okay? Since your equation is in the term of y over x, and then our definition that, our assumption that we give v equal to y over x. So we can change differential equation into dv by dx as a function of v and x. By doing this way, we would end up with separable equation. And then we solve this equation by using separable equation technique. Then we would end up with v as a function of xv. And then we got to put it back, replace v equal to y over x. Then we would get the final solution as y as a function of x and y. This is called the homogeneous equation. This is the way to find the answer for the first order differential equation, which is in the form of homogeneous equation. And here's the example. This is the example. Find the solution of this differential equation. If this equation is the separable equation, can you put x with dx and y with dy? Can we? No, we can't. So, if the equation just go like this, don't try to use separable equation to find the answer, because you can't separate x and y out of each other. Now, the second method that I am teaching you is homogeneous equation. So we got to figure it out whether this equation is the homogeneous. From the definition is saying that if this equation is a homogeneous equation, then you should be able to write dy by dx as a function of y and x, y over x. Okay, so we try to do that way again. by dx is equal to what? Divide there, um, right? Right? And then it says take x out. Right? So this equation, you can rewrite it in the term of y over x. So from this, you can say that this equation is a homogeneous equation. Then the way that we are finding the answer for this equation, we are going to use the homogeneous equation method. So first, we got to assume v equal to y over x. And from this assumption, we would end up with dy by dx is equal to v x dv by dx plus v. Okay? Let me put this one as the equation 1. And this one as the equation 2. No, this one is 2 and this one is 3. So from this, I put 2 and 3 into 1. Then I would get x dv by dx plus v equal to v minus 1. Now you have only v and x. V become dependent, our dependent variable. And then we just, make the equation more simple. Is it a separable equation? Is it a separable equation? Yes, it is. By this definition, by this assumption, when you change the dependent variable y to v by using the assumption that v is equal to y over x, and then you can write dy by dx is equal to x dv by dx plus v. Putting this assumption into our differential equation that we write it down, we rewrite it in the term of y over x, then the final equation would be in the term of dv by dx as a function of v and x, and this equation will be the separable equation. And the way to find the final solution is just using the separable equation technique. Okay? Then I would get and then we do integral for both sides. We would get v equal to negative ln x plus c. But we can't answer this because our problem statement itself doesn't have v. So we got to put v equal to 5 over x, which is our assumption, back into this equation. So we would get y over x equal to negative ln x plus c. That is the answer.